So first of all, thank you all for coming. I really appreciate it. I know University Research Week is kind of packed with a ton of events, so I really appreciate you taking the time to come to this one. And I hope you enjoyed the cookies and the various seltzers. It was interesting seeing like which one people preferred. Obviously, raspberry lime was the winner. So my name is Peggy Mullin, and I am the research technician with the Carolina Drone Lab, or Cardinal. We, as said in the video, we're a research lab unit on campus that focuses on using drones to augment folks' research on campus. So today we're going to be speaking a little bit about how we've been using drones in tandem with student research to get a closer look at our green roofs on campus. So right now, as we speak, you are standing on a green roof, which is probably not surprising because if you turn around, there's all sorts of greenery behind you. So how many folks, put up your hands, know what a green roof is? All right, cool, awesome. How many people knew that there were green roofs on campus? Okay, so like somewhat medium, small amounts for both. So we have 8 different green roofs, depending on how you define green roofs, on UNC's campus. And this is a map showing where they are. So if you use Kenan Stadium as your landmark, we have Loudermilk Center for Excellence roofs here, Rams Head Plaza down near South Campus. We then have the Genome upper and lower roofs, the FedEx Global Center roof, which is the one that we're standing on right now, and then down here the Curry and Mary Ellen Jones building roofs. So green roofs broadly are roofs incorporating vegetation to provide various benefits aside from those that would be provided by a typical roof structure. So when you think of a typical roof, it's very impermeable. It's designed as part of a built environment to have water protection. Water comes on it, runs off of it, and then goes into stormwater. So green roofs use usually some variation on the medium that you're seeing over here, where there's a layered approach, kind of this layered cake. So vegetation on the top, growing medium and irrigation and drainage layers, filter fabrics, roof barriers, and a waterproofing membrane to prevent it from affecting the roof structure underneath. And green roofs have been shown to increase the longevity of roofs themselves. They also really provide benefits for all sorts of different things like stormwater infrastructure. So stormwater, if you think about when rain falls on a flat surface, it collects, runs off, and then goes into your stormwater infrastructure. When we have highly impermeable surfaces, it results in stormwater collecting a ton of pollutants at once, running off really quickly, and affecting our water quality. So that's why we have problems in water quality in areas that have poor stormwater infrastructure, when we can engineer solutions like green roofs that help us percolate that water slower, store it underneath of the roof, and then distribute it to maybe different sources where we can reuse that water or pump it back into the stormwater infrastructure at a predictable rate to manage stormwater. So in this building, actually, if you've ever been to the bathroom here, or if you go to the bathroom during this talk, there are these signs that say, "Don't drink this water," over the toilet. And the reason those signs are there is because we reuse some of the rainwater from these green roofs, and it's, you know, health code mandated to say like, hey, don't think about that. It has pollutants from the green roof, but at the bottom it says like, we weren't really thinking you would do that, this is required. So that's a pretty interesting fact about this roof, and there's a few other green roofs that have that same cistern or kind of tank infrastructure underneath of them. Then it also provides thermal insulation, so an additional layer of vegetation can help the roof maintain its cooling, and it aids the ability of a building to stay cool in the summer months. And it also reflects a bit more of solar insulation, or the amount of solar radiance coming in and reflecting off of the roof. It helps that effect to be a little less pronounced and reduce overall thermal load on the roof itself. And it also provides vegetative habitat, like I was mentioning in that video. So some pollinators especially need stopover points to be able to connect to a network of other pollinators. It helps the other sort of islands, as this project's name implies, be able to provide the same habitat and vegetative structure. So both for animals and for plants, it's important to have these pods of vegetation in the landscape. And also it provides an aesthetic benefit. So, I mean, if you haven't been here before, you should come up here and study sometime. It's really nice to just be surrounded by plants instead of, I don't know, you ever been in the Kenan Labs building? That building's the worst. It's just built, and I understand why. But this is a really high benefit of the green roofs on campus. It's ways to have gardens that are also providing services for the buildings they're on. So a brief overview of the Carolina Drone Lab, like I said before, we're a drone research unit that augments other folks' research and ties in with ongoing research efforts to get a top-down view and an aerial perspective. We work with all sorts of different organizations all over the world, but we are based at UNC, and we really pride ourselves on touching every bit of different research around the university. And we've been really fortunate to work with a whole suite of researchers. So when we were coming up with the idea for this project, we were lucky enough to get supported by a grant provided through the Lenovo Center for Faculty Excellence. They have a call for proposals every year that goes out to faculty and says, hey, do you have any ideas about ways to augment student research, ways to augment student involvement? So we had an ongoing conversation with some managers of these green roofs and wanted to figure out how to tie in student research into green roofs. So we came up with the Islands in the Sky project, and the project aims three-parter mainly. So first, as I mentioned before, not too many people are aware of the green roofs. That kind of extends outside of UNC. And we're a pretty unique space in the Southeast. Like, we have our unique band of climate and the way that the green roofs behave and act here. So we want to highlight the way that these green roofs are performing, maybe underperforming in this area, so that we can take those results and learn a little bit more about how to build green roofs in other areas in this similar climate. So improving campus green roof awareness, gathering basic data on the green roofs, and facilitate student-led efforts like you're going to hear about in just a bit. So why drones? It's sort of a silly picture, but if you think about satellite data, that's sort of like what a lot of long-term researchers use. Satellites are super high up. They get pretty astonishingly incredible resolution, usually down to about 30 meters per pixel. That is. So when you see an image from a satellite, each pixel is represented in real life by a 30 by 30 square. For drones, that can get down to about 10 centimeters, which is awesome. It's a huge improvement on resolution. And while it's not a one-size-fits-all solution, like drones aren't the perfect thing for everything, it's a really interesting way to augment site-specific research. So for this project, I won't bore you with too many of the details, and we can talk about them later if you're interested, but we were using about 3 different types of drones. So first we have the Anafi Thermal. That's this drone up here, and it's just about this big. It's kind of holds right in your hand. It's like a little, I don't know, miniature dog. And folds out, folds into a little briefcase, and this one in particular has a thermal sensor. So that thermal sensor is capable of rendering thermal images, still images, as well as true color images. Then we also have the DJI Phantom 4 RTK, which is this white drone up here. Maybe you see videos of that on YouTube or something. A lot of photographers use that a lot of the time. It's like the mid-range, high photo. It's preferred by a lot of photographers. And that changes as new drones come out. But the benefit of this one is that this black bracket isn't standard. We put that on there so that it could carry a 5-band multispectral sensor. So all you really need to know about 5-band multispectral and what that means is that your typical camera sees light in 3 ways. It sees red, green, and blue. And down here, just a general rendering of the electromagnetic spectrum. I apologize, this isn't on the projector. The projector isn't working. But when you think of visible light, you see blue, green, and red. 5-band sensors and other multispectral sensors are able to extend that range of light that it can actually see with its eyeball, basically, to, for this case, red edge and near infrared. And those bands can tell us really important things about all sorts of different key indicators. And in this case, we were interested in looking at vegetation. So there are different ways that you can look at those bands of light, and then ways that you can understand those readings to see how a plant is performing. So a green plant will register really high in the green, and a dying plant will register usually really high in the red. So you can compare those two things to render a ratio and understand a little bit about how plants are doing. And then the Skydio 2 is the third drone we were using. That is an AI-controlled 2D and 3D true color drone. It's pretty much performing the same task as the other true color drone, except this one is AI controlled. And I know that's a buzzword, and everybody loves AI, but in this case, it just has a really intelligent computer on board and a bunch of eyeballs. And because of those eyeballs, it's able to take off in a space, look around for a couple minutes, understand like where that chair is, where this person is, where that table is, and steer around those obstacles to almost like a 3-foot radius. it's really, really good for high quality mapping in 3D and 2D of infrastructure. The other benefit is that it's not susceptible to magnetic interference, which is super common on built infrastructure. So outcome number 1 of the project, and I'll keep myself on pace for y'all to present, is student impact. So as I mentioned, this project is funded for students who want to embrace student research and lift them up. So we were able to fund 3 different student interns, including Claudia, who's here today, as well as Steve and Gabby, my other 2 interns, and each of them performed an independent research project, learning how to fly drones, learning what goes into mapping and flying those drones. And that's a really valuable skill for a bunch of different jobs, not just vegetative monitoring, but pretty much anything you could think of in this day and age, right? Everybody is interested in using drones for new and innovative things. And then we also worked with the Sustainable Triangle Field Site Capstone in spring 2023. There's also a contingent of students here today from that, including Claudia, and we're really excited for them to highlight their research that's demonstrated on the poster over there. So outcome number 2, monitoring green roofs with drones. So as a result of this project, we produced 16 different 2D and 3D true color maps of all 8 green roofs on campus. And we had 3 different student-led explorations using drones to analyze vegetative cover, looking at thermal, looking at NDVI, and looking at percent cover as different ways to understand the roofs themselves. So for each indicator, we were using Pix4D Capture. So this is a screenshot from a cell phone. This is a free app that you can download onto your phone right now from the App Store, and it's called Pix4D Capture. Basically, it loads a base map. You can drop any map on here and connect it to a drone. So you'll fly a drone with your phone plugged into a controller, and it can understand the map that you're laying down, the height at which you want to fly it, approximately how long that flight is going to take, and how many laps you'll need to do. So it can do 2D, low-key 3D, and then it can also do thermal mapping as well. So it's a really excellent app that's now newly available for free to anybody to use. So this is just an example of one of those student-led research efforts that I was talking about before. So this is from Steve's arm of the project, and a bit about what I was talking before were that different near-infrared and red indices. So NDVI stands for Normalized Difference Vegetation Index. It's one way that remote sensing scientists use to understand vegetative health. So that is one indicator, and then, I don't know if this is going to show up, but NDRE is a different one. It's the Normalized Difference Red Edge Index, and those 2 are really interesting ways to compare vegetative health. So over here, this is the very roof that we're on right now, the FedEx green roof. We have the true color image in RGB space, and then we have the Normalized Difference Vegetation Index. So on this map, red is showing up in the parking lot on the non-vegetated side of the roof, whereas green is showing up where there are trees and where the roof is vegetated. And that's because it's set to values of 1 and -1. So you're expecting more photosynthetically active areas to show as green, whereas least or non-photosynthetically active areas show up as red. So one interesting sub-indicator from this map is this little green speck here. So can anyone throw out an idea of maybe why it was so green in an area of like less green? Perhaps if this item was nearby? Yeah?
Perhaps like temporary or intermittent shading instead of direct sunlight.
Totally, I think it's a really good theory. We don't know the exact reasons, but it's a vent. It's blowing air all the time. So we're thinking maybe it has something to do with temperature and humidity as well as shading, and it's creating a microclimate in that area of the roof, which if you look out there right now, it's not as apparent to your eye, but you're able to pick it up on this map. So it's a way to, in general, NDVI is used for all sorts of different things. In this case, we're able to pick up on these small nuanced differences between areas of the green roof using this technology because it's at such high resolution. If you were doing this with a 30-meter resolution Landsat data set, it would be really hard to pick out those finite details. So key lessons learned from this outcome of the project. First of all, magnetic interference definitely matters. So on roofs, this whole building is constructed with rebar. There's metal everywhere. And that really affects the drone's ability to understand where it is in 3D space. So not only does it affect where it thinks it is, but it affects where it thinks it's meant to go. So that can be a real problem when you're using software to tell a drone, hey, I want to fly over there. So in this case, we had some magnetic interference issues intermittently in the project, and it definitely affected our ability to perform. So in that case, I found that the Skydio, again, that AI-controlled drone, did really, really well because it was able to see where it was going without needing to reference to a third-party satellite or GPS. So although it's really expensive, definitely the most expensive of all the options, of course, that is the best one for this job. So thinking longer term to like, how can we improve facilities management of these green roofs? How can we keep track of these things? That would be my recommendation of what to use for this case. Again, finding the right tool for the job. Then for the thermal, we had a little bit of issues with mapping and thermal. Sometimes thermal mapping will show up as a kind of reflectance value, and we had trouble correlating that directly with the temperature value. And we think it has something to do with the thermal mapping capabilities of the software itself. So that was an interesting finding, considering the software and the program told us that it would work a certain way and then it didn't. So interesting to learn. Also the multi-spec, again, that white drone with the black bracket underneath was totally the most susceptible to magnetic interference. And that's undoubtedly because you're attaching something that isn't factory supported onto a drone, and further confusing it because you have to disable its auto awareness and a bunch of different factors. So that was sort of an exercise with my interns in learning a little bit about best practices for using this technology, and at what point you say, okay, this drone isn't necessarily the right tool for the job because we can't say for certain that it's going to do this job well. Then also TrueColor, we found that it had great utility for monitoring roofs from ground level. So when people come up to water and weed and manage these green roofs, they need to, in the middle of the summer, go out on the roofs, get on their hands and knees, weed, take a look, manage. There's 8 different roofs on campus. And a lot of these require safety classifications too. You have to get trained, you have to have a certain harness on when you're working on the roofs because it's all like safety relevant. Even though there's this wall to the side of the green roof, that's mainly to keep wind from knocking people off and from getting into the green roof itself. It doesn't really qualify as an actual safe space for people to be walking out on. So there's all sorts of safety considerations. With drones, I could pop a drone up from the ground level, take an inspection quickly, and in 1 minute or 2 minutes, tell whether I needed to do any work on that roof that day, and then move on. So that represents a huge time savings for these people that work really, really hard to maintain these facilities on campus. And we also explored percent covered monitoring. So green roofs themselves need at least 70% vegetative cover to work as they're expected to work, and monitoring that from the ground level can sometimes be difficult. Even just looking out there now, it's hard to tell where there's vegetation and where there's bare ground. So from a top-down view, you can run it through GIS software or some other way to classify pixel by pixel what you're seeing as green or non-green, and then that way you're able to get an estimated percent cover and again, move on to the next roof really quickly. So we improved the green roof's outreach materials as our third outcome of this project. And not only did we have these totally new maps and 3D models, but Abigail, wonderful Abigail in our outreach team, totally revamped the green roof website. So now in Sustainable Carolina, we have a hosted virtual green roof tour. So it tells you a little bit about the project, a little bit about the details of what we did, and then for each green roof, we have a drop-down menu with imagery and a summary of the features of each. And then we've also tied it into the overall campus map, which is typically what you'll pull up on the, I think, Carolina Go app if you're trying to navigate around campus. So we've added green roof listings for each of the roofs on campus, and we encourage people to go visit them. And then for this week, I took the liberty of printing out some UNC Research Week posters and posted them at each green roof on campus. So if y'all are feeling like it, I encourage you to go around, find these signs, scan, read a little bit more about the roofs, and take an interactive tour throughout campus. Start to notice these little things around campus that you may not otherwise notice because they're fun and interesting features of sustainability on campus. And if you wanted to go to the website, this is the QR code. All right, well, thank you again.